Recording. Okay, again, I would like to welcome you all here in our first online lecture, which is on Thursday. So I hope the experience is going to be great for all of you. I'm trying to do my best so that you will be having the same environment in the class. Please, again, those who join the online lecture, please turn off your microphone so that the voice is going to be clear for everyone. Okay, now do you see the slide here? All of you?
Yes, we can.
Okay.
Yeah, we can see it.
So again, please, those who come new, please turn off the microphone. I'm going through the lecture. I'm going to ask a couple of questions. You know my style. I always ask questions. So if you know the answer, you can open your microphone and answer the question. Okay. Now, please turn off all of your microphone. Only if you have an answer for a question, then please open the microphone and answer the question. Okay. So let's start here. I would like to welcome you again in the first online lecture in Geology 144. Today we're going to talk about a very important topic, which is weathering. Okay. So anyone can remember the term weathering? We used to discuss the weathering in which topic that we previously discussed. Anyone can remember the weathering?
Doctor. Yes.
In which topic?
In sedimentary rocks.
In sedimentary rock. With in which context?
Sediment. Creating sediment.
So the weathering was the first step in order to create sediment, and we also say that the weathering, it could be physical or it could be chemical, right? So we have physical weathering and we have chemical weathering. And I do remember that you used to have a lot of questions about the weathering. So today we are going to discuss, or we are going to cover the weathering in great details. Okay. So let's get started. When we say weathering, weathering means a process that breaks bedrock into smaller rock and mineral fragments and eventually into soil. So when we say weathering, that means we are going to break down the rocks into a smaller one, okay? And that it will result in mineral fragments, and eventually, if the weathering process continue for a long time, eventually we will have the soil, okay? And the soil is very important for us as civil engineers, because if you want to construct anything, it should be constructing on soil. So weathering process is very important process, and as a result of that, you will end up with the soil. So weathering involves physical breakdown and chemical alteration. We already discussed this. We said that the weathering, it could be physical or it could be chemical. So we need to differentiate. We need to know the difference between physical and chemical weathering. When we say we have mechanical weathering, it means that we have physical forces breaking rocks into smaller pieces without changing the rock's mineral composition. So the bottom line here, or the main idea here, you will have forces that it will break the rocks, but the composition is going to be the same. So if you have one big rock, then because of the weathering, it breaks down into two rocks. The composition of rock number one and rock number two is going to be the same. So in mechanical weathering, the forces, we have physical forces will break down the rocks, but the main idea is the characteristics of the new breaking rock is going to be the same as the parent rock or the mother rock or the bigger rock. Okay, while as in chemical weathering, it involves dissolving of minerals or chemical reactions that replace the original minerals with new minerals that are stable at Earth's surface. So in chemical weathering, the original minerals is going to be replaced with new minerals. Whereas in the mechanical weathering, we will keep the same kind of mineral composition. So in mechanical weathering, we're going to keep the same structure. Whereas in the chemical weathering, we are going to have new minerals as a replacement for the original minerals. Okay? And we need to know that both work simultaneously and reinforce each other. Yani it means that the mechanical process is not going to work alone, or the chemical weathering is not going to work alone. Both of them will try to work together and will try to support each other. Okay? So anyone has any question about the difference between mechanical weathering or chemical weathering? Now you can open your microphone if you have any question regarding this. Yeah, is it clear for all of you? Does it make sense?
Yeah, clear. First is physical, the second is chemical, right?
Yes.
Chemical.
Do you know the difference between them?
Yes.
Yeah.
The difference between them in physical, we have the same things, and in chemical, we have a new things after the processing.
Yes. And they will work at the same time, and they will support each other. Okay. So if you have a small rock here, you can see the rock here. It has area, right? The surface area of this one is going to be 4, right? Because the dimension here is 2 and the other dimension here is 2. So the area here is going to equal 4, right? Then how many slides do we have in one cube? You will have 6 slides. Okay? That means the total area of that cube here is going to equal 24 because we only have one cube. So again, we need to calculate the area of that rock here on the left hand side. If you take only one side, it has dimension of 2 and 2, which means that the area here is going to equal 4. And then I have 6 sides, 1, 2, 3, and other 3, which you cannot see. One here, and one here. Then if we need to know the total area for that cube, it will equal 4 multiplied by 6, which is 24 square units. Okay? So we know that the mechanical weathering breaks rock into smaller pieces. That means the area is going to be increase or decrease, or is going to be the same. An idea? Assume that I have this cube here. Then as a result of mechanical weathering, instead of having one cube, I will have 8 cubes. Then do you think the area, the surface area, the exposed area is going to be the same, or it's going to increase or decrease?
Increase.
Increase,
Doctor.
It will increase by how
Stay the
much?
same.
Any idea by how much it's going to be increased? If this one break down into that one, instead of having one big cube, now I have 8 small cubes. Then the area, you say that the area is going, the surface area, the exposed area is going to be increased. Do you know by how much?
2 times.
8 times.
By 2 times. It's going to be increased by 2 times. Why? Again, if this one is 2 and 2, if you have 8 cubes, that means only the one cube, it will have dimension of 1 by 1, right?
Right.
So if this one is 2, then this one is going to be 1, and this one is going to be 1. Now, the surface area of one cube, one small cube, is going to equal 1, right? But how many sides do you have? Again, I have 6 sides. So the area of one unit is 1 square unit. And for one cube, I have 6 sides. But here, instead of having only one cube, now I have how many cubes? I have 8 cubes.
8 cubes.
So if you multiply 1 by 6 by 8, you will end up with 48 square units, which means that the number is twice as much as the previous one, the original cube, right?
Right.
So what if you double the process again, which means that each cube is going to be divided by another 8 cubes. That means again the surface area is going to double again. So the main idea about this, as mechanical weathering breaks rock into smaller pieces, more surface area is exposed to chemical weathering. Okay, so we know that in order to have chemical weathering, we need to have a contact between the chemicals and the rocks, right? Then, if you have more area, the chemical attack, will it be more or less?
More. Less.
So if you have this cube, and this cube is subjected to chemical weathering, and you have those cubes here, and also is going to be exposed to chemical weathering, which one is going to be affected more, the left hand side or the right hand side?
Right hand side.
Right hand side.
Why the right hand side?
It's small. The surface, the cross area is
because
small, right?
the exposed area is more than that one. That means the damage is going to be more because the contact is more than the original one. So the mechanical weathering is going to help the chemical weathering. Like we say, both of them will work at the same time, simultaneously. Okay? Is that point clear for all of you? Do you have any questions regarding this?
Yes, please. I didn't get the point why the chemical, why the right hand side is more than with chemical.
Because the area that you see here, do you agree that the area on the right hand side is more than the area on the left hand side?
No, the area is less, right?
The area on right hand side, this one.
All of them.
Is it more? Is it more of more than that one? Yeah.
The exposed area is more.
I think yes, it's more.
If it's more, that means when these cubes here, when they come in contact with chemical, that means the effect is going to be more or less, or it's going to be the same?
More.
Why it's more? Because the exposed area is more. Okay, which means that the mechanical weathering is going to help the mechanical weathering is going to help the chemical weathering by increasing the surface area. So we have interaction between the mechanical weathering and the chemical weathering. Okay. So let's move on to talk about the chemical weathering and the types of the chemical weathering. We know that when a rock undergoes mechanical weathering, it's broken into smaller and smaller pieces. We already discussed this point. And again, we say that each retaining the characteristics of the original materials. Even though the original rock is going to be divided into smaller rocks, but even though the characteristics of one unit is going to be the same as the original unit. And we say that in the chemical weathering, the situation is totally different, right? Because in chemical weathering, we'll have new minerals is going to be replace the original minerals. So also we discussed that breaking a rock into smaller pieces increases the surface area, which is going to be available for the chemical attack. So in the previous picture, we discussed all of these ideas, okay? So we need to know the mechanical weathering takes place in 4 ways. And in nature, we have 3 methods or 4 methods in order to increase for the mechanical weathering to take place. So the first one is freezing of water. The second one is formulation of salt crystals. The third one is penetration by plants' roots. And the last one, or the fourth one, is the abrasion process. Now we need to talk about the first one, which is the freezing of water. Remember, if you have a bottle like this one and you filled it completely with water and you put it in the refrigerator,
Doctor?
after a very long time, what do you think will happen? Again? If you have a
excuse me,
bottle of
doctor.
water, okay.
Dr. Mulham is trying to reach us from the beginning, but he can't. Can you just invite him or something?
Who is one to be invited?
Mulham. Mulham.
Okay. To check him. Mulham. He's not with us. I will
No,
try
he's
to
not.
call him. I will try to call him. Now I'm calling him. I hope he's going to answer. Okay, let's continue. I'm going to repeat the questions again. Do you see the PowerPoint, all of you?
Yes, doctor.
Yes. Yeah, we can
We
see it.
said that. We said that if we fill a bottle of water, completely with water, and then we put it in the refrigerator after a long time, and assume that the bottle of water is made from glass. After a long time staying in the refrigerator, what do you think will happen?
The glass will explode.
The glass will be broken.
Why?
Will be broken.
Why the glass is going to be
Because
broken?
Because the volume of water will increase.
the volume of the water, when it's converted to ice, it will increase, and this will cause the broken glass.
Yes, very good. We know that the expanding is going to be about 9%. So if you have a liquid water and then the liquid water converted to ice, then we will have expansion of about 9%. And that expansion in volume, it will cause the breaking of the glass bottle. Okay. So the same thing will take place in rocks. If you have a rocks, you know that the rocks include voids inside it, right? So that voids, it could be filled with water. And if that water freeze, it will cause additional stresses because the ice, it has a volume more than the liquid water. And that will break down the rocks. So again, the rock contains water inside its voids because rocks mainly it has voids inside it. And if you have the freezing condition, then the volume of the liquid water, the volume of the liquid water is going to be expanded. We say that by 9%. Then if you have expansion, you have increase in the volume of the ice, that will create tensile stresses. The tensile stresses will result in broken down of the rocks. Okay, so if you can see this picture here, you have a water which is frozen. That water, it will create tensile stresses, and as a result you will have breaking down of the rock. You see here, this rock here used to be 1 unit, but because of the freezing of water inside the rocks, that result into a breaking.
We don't see, doctor, anything.
You don't see? Okay, let me check. Do you see now?
Just the bottle.
No. Yes, but I think you need to flip the slide. Yeah, that's right. That's good.
Is it clear for all of you right now?
Yeah, it's clear.
Yes.
So again, assume you have a rock, and we say that the rock contains voids, and that voids could be filled with water, okay, liquid water. And if that liquid water was exposed to freezing condition, that means the volume, it was going to be increased. If the volume increased, that means tensile stresses will take place. And if you have tensile stresses, that will result into breaking down of rocks. Instead of having 1 unit, now I have 2 units. And it could be more than 2 units. It could be 4, it could be 5. It depends on the voids, and it depends on the location of the water. You see here in that rocks, I have ice. Of course, it used to be liquid water. And when it's exposed to freezing conditions, you know that the volume is going to be increased, and as a result you will have tensile stresses. It will result in breaking down of rocks. You see that big rock here, it used to be a 1 unit, but because of the water inside it, which was exposed to freezing condition, now I have 2 units instead of 1 unit. Okay, so also we call the freezing of water frost wedging. It has another name. Instead of saying freezing of water, we can say frost wedging. Do you have any question about the mechanism that the freezing of the water is going to make weathering, chemical weathering, or mechanical weathering? I think it's clear, right?
Obvious. Yeah, very obvious.
So let's move on to another type. The other type is the salt crystals growth. It means that the salt crystal is going to be grow inside the rocks, which in return it will going to increase the cracks inside the rocks. So from where we can get salts? We know that the rocks is maybe it's going to be exposed to water from the sea, and we know that water from the sea, it contains high concentration of salts. Also, it could be result from groundwater. We also know that the groundwater sometimes contains concentration of the salts. So sea spray or salty groundwater infiltrates. Infiltrates means go inside the voids in the rock. Infiltrates make cracks and pore space in the rocks, and as water evaporates, salt crystals form and enlarge the cracks. And if I have a rock, then maybe this rock is going to be exposed to water from sea, or is going to be exposed to a water from groundwater. We say that sometimes the groundwater maybe is going to be salty. So in that case, when the rocks is going to be exposed to groundwater, when the water evaporate, like you see here in this picture, eventually the formation of crystals of salts is going to take place, and in return is going to widen or enlarge the cracks. Okay, like this picture here. Any questions about the formulation of the salt cracks or salt crystals?
دكتور هلا يعني الملح اللي في باطن الأرض هو اللي يشكل الكريستالز هاي؟
Yes, actually the salt with the water.
تمام تمام. شكرا.
Okay. Anyone have any
Doctor,
questions?
excuse me. Where did the يعني من فين جاء الملح هذا؟ يعني جاء من مية البحر، يعني انجرفت على الصخور هذه، ولا يعني أنا ماني فاهم كيف جاء الملح هذا أو كيف تكونت السالت كريستالز هذه؟
Do you drink water from the home? That you drink water, or you buy water from the supermarket?
Yeah, from the supermarket.
Why?
Because I can't made it. I can't make it.
But you have water inside your home. Why you buy water from supermarket? You got my idea?
Get your point.
You got what I'm trying to say? Did you get what I'm trying to say?
Hopefully, yes.
Because we here, for example, in Medina, we used to get the water from wells, right?
Mm-hmm.
And it's the groundwater.
Yes.
And the groundwater usually it contains salts. Okay.
Yeah.
And you know that the water from the sea also contains salts.
Much like Zamzam, it contains also some amount of salt.
Yes, that is why sometimes I know it's real or not.
Yeah.
So when the water evaporates, it will leave the salt crystals
on the rocks. Mm-hmm.
And this one, it's already inside the voids, inside inside the rocks.
Mm-hmm.
And you have, if you have crystals inside the the spaces that it will enlarge the cracks. Okay.
Yeah.
Is it clear, right?
Thank you.
Does it make sense for you?
Yeah, very obvious. Thank you.
Okay.
It makes sense.
Let's move to the third one. The third one is penetration by plant roots or root wedging. We know that sometimes, I think all of you may see a tree that grow inside a crack in the rock, right? You may see something like that.
Yes.
And any tree, it has roots, right? And the roots, with the time, it will grow. Like you see here. Any tree, it has roots. And if you have a tree that which grow inside the voids in the rock, the roots, it will grow with the time. And if the roots grow with the time, what will happen to the rocks holding the trees? It will break down into small pieces, right? So
because
now
of the chemicals of roots.
It's because of the
chemicals of the roots. Yes.
Because of the chemical of the roots, of the growth of the roots.
Both.
I think the growth.
What is the main reason?
The roots produce some chemicals, so it will will solve the rocks.
Yes, this is one way of seeing the picture, but also the growth of the rock itself, it will break down the rocks, right?
Yes.
We know that the rocks may have carbon dioxide, right?
Yes.
And the carbon dioxide, when you have carbon dioxide and you have a water, then you will have some kind of acid
reactions. Yes.
So also this one, it will go into break down the rocks, but this one is chemical weathering, not physical weathering.
Yes.
Okay. So but now we are talking about the penetration of plant roots in terms of mechanical weathering. Okay.
Okay, I got it.
Okay. Now, anyone has any question about the penetration by plant roots?
Doctor, we can explain that, as we said before, chemical and physical, they are
working together. Yes. Work together at the same time.
So ملهم saying something يعني هي عنده وجهة نظر برضه. احنا اتكلمنا ان هم برضه الاثنين بيتعاملوا مع بعض فبيتم عملية انه هو بيصير عندي الويذرنج، صحيح؟
Yes, they support each other. Okay, let's move to the fourth reason, which is abrasion. Abrasion is the gradual wearing away of bedrock by constant battering. When the term battering here means the action of striking repeatedly with the hard blows. So, you know, we said that the sediments, it could be transported by water or wind or ice, right? But the winds, it will take loose particle with it, right? So in the way of transportation from one point to another point, while the wind or the river or the water or the ice carrying loose particles, these particles, it would has like fraction with the existing rocks on its ways. So that will create a loss in a surface of the rock. So if you can see this rock here, if you have a wind which is carrying some loose particles, the wind will try to go from that point to that point. On its way, it will try to make frictions with that apparent surface of the rock, and that will result in loss of the surface of the rock. Okay, so this process is called abrasion or wearing. Okay, so abrasion or wearing, it means that the loss of the surface of the rock by wind or water or ice which are carrying loose particles. Okay, so this one is just like if you have a sandpaper. You know the sandpaper? The one we use in order to soften a surface. So the process is similar to this one. We use a sandpaper in order to soften a surface, but here the operation, the sandpaper is like the wind that carrying the loose particles, or water carrying loose particles. It will try to soften the surface of the rock. As a result, you will have breakdown of the surface of the rock.
Doctor, what is this sandpaper?
Anyone can answer him? Anyone knows the sandpaper?
Sandpaper is the dark paper you use on the wall. It comes in grit rating, like 1,500, 3,000. You can find it in Sacco also.
Okay, thank you.
Okay. Any other questions about the operation? Okay, let's move on. Again, we said that we have the freezing of the water, and it's clear for all of you. We say that as water freeze, it will create tensile stresses. It will result in breaking down of the rock. We have the formation of salt crystals. We say that the rocks, it could be exposed to water from sea or from the groundwater. And when this groundwater penetrates inside the voids in the rock, when the water evaporates, it will leave salt crystals, which in return is going to enlarge the cracks, or it will result in breaking down of rocks. Also, the penetration by plant roots. We said that some plants may grow inside the voids in the rocks, and when the trees is going to grow, the roots, it will grow with it, and the roots, when the roots grow with it, it will result also in breaking down of the rocks. And the last one is the abrasion. Abrasion is a process, or sometimes we call it wearing, which means that the transporting agent, whether it's wind or ice or water, is going to take or is going to carry some loose particle with it from one point to another. Through that process, friction will take place between the carrying particles, and that will result in loss of the surface of the rocks. We say that this process is similar to sandpaper. Okay, so anyone has any questions about the mechanical weathering that takes place?
دكتور بالنسبة للابريشن بروسيس انه هي مثلا يعني لما اللي هي الجبال الجليدية لما يذوب الجليد اللي على قمتها بياخذ معاه بعض من الغطاء الصخري يعني للقمة نفسها. هذا المقصود يعني؟
Yes, it's one way. It could be also by wind or it could be by water.
Or ice, right?
Yes.
Thank you.
Doctor, it's also similar to if you scratch your skin against a rock, you will have abrasion on your skin. A small layer of the skin will be removed. They call it abrasion also in the medical term.
Yes, you are right. Also, we have abrasion in the concrete itself. For example, if you have a sewers, do you know the sewers? The sewers, we use the sewers in order to facilitate the movement of the water. Okay, and mainly it's going to be made by concrete, but we know that the water, it will carry some sediments with it. In the process, a part of the cement surface, is going to be removed. Also, is abrasion in the concrete. Okay, so the abrasion term, it could be used in medical, it could be used in geology, and it could be used in concrete. Okay, so it's
Doctor, what's sandpaper? He said it, but I didn't hear it.
Sandpaper. In order to paint a wall, for example, if the wall is very rough, or if you want to paint a door, say a door made from iron, okay, do you usually put the paints against the iron door, or maybe you can make some kind of processes?
I don't know, doctor.
You don't know? You haven't seen something like that?
دكتور انت تقصد ورقة الصنفرة يعني من الآخر صح؟
Yes.
ورقة الصنفرة يا شباب. الله يعطيك العافية.
شو هو يا دكتور؟
Okay, I will try to send you a picture for sandpaper if you didn't get it from here.
Thank you.
Okay. seem like you haven't seen something like this before.
I will search for it. Thank you, doctor.
Okay, you are welcome. So we covered the 4 ways in which we can see mechanical weathering. I want to check if we have time for. I'm afraid that we only have 3 minutes. So next time we'll talk about the chemical weathering. Okay. So anyone has any question about the mechanical weathering? I think the online lecturing takes a lot of time, right? Not like we used to be in the class.
Yes, I agree.
Yes, doctor. Yes.
I hope some of you will not going to get bored because of the
No.
a great deal of explanation. I know some of you might get bored of.
Yeah,
No.
so relaxed.
No, it was interesting with you, teacher.
Okay, if you have any comment regarding the online lecturing, any means or ways through which we can enhance the online lecturing?
No, doctor, but I have a question. Thank you very much, doctor.
No, we don't. Thank you very much.
So
Doctor.
you are welcome. I'm going to
you
say your
marked
names
me
again.
then?
Tariq, are you here? Tariq Muhammad, are you here?
Yes, doctor, here. Yes.
Any problem with the online lecturing? Is it
No.
working for you? Okay, Abdurrahman
Good.
Attas, are you here?
But doctor,
Yes, doctor. Yeah.
I can't
any
reach
problem?
to you
Because
doctor.
you know what happened?
No.
Abdurrahman Attas told me that you dropped the course. So when in the process of adding a student to the teams, I didn't add you. Okay, but he told me later on he didn't drop the course.
Yeah, doctor, I didn't drop the course.
Okay, I will add you again. Okay, no problem with that.
Okay,
Rahman
thank you,
Attas, are you okay with the online lecturing? Any problems?
No.
Hassan and Murad, do you have any problem with the online lecturing?
No, it's okay, doctor.
Okay. Anyone who hear his name, he can go. Okay, the lecture is over. If you heard your name, you can go. Mijal, are you here with us?
Yeah, موجود.
Do you have any problems with the online
was
lecture?
great.
Okay, thank you. You're welcome. You can go right. Hussein Muhammad.
Yes, I'm here.
Yes, you are here. Any problem with the online lecturing?
No, everything is okay.
Okay, you're welcome. You can go
Thank
here.
you.
Iyad, you're welcome.
Yes, doctor.
Any problem with the online lecturing?
No, just if Jihad closed his microphone, everything is good.
Okay, you can go right now. Thank you for attending.
Thanks.
Abdul Malik Al Ghazi, are you with us? Please close the. Please close your mic, please. Okay, Abdul Malik Al Ghazi, are you here? He's absent. Mulham, are you here?
Yes, I'm here.
Do you enjoy the online lecturing? Do you have any problems?
Yes, it was very interesting.
Okay, you are welcome. You can go right now. Muhammad Rashid, are you here with us?
Yes, I'm here.
Do you have any problems, any suggestions?
No, I don't.
You can go right now. Thank you for attending.
No.
Ahmed Malik, are you here? He is absent. So Abdul Aziz Tuhami, are you here with us?
Yes, here.
Any suggestion, any problems?
No, everything is good.
You are welcome. You can go right now. Omar, do you have any questions, any problems?
No, it's all good, doctor. Thank you.
Okay, you are welcome. You can go right now. Abdullah Ibrahim, are you here?
Yes, sir, I'm here.
Okay. Any suggestion, any problem with the online lecturing?
No, the way you provide it is very awesome. It's really awesome. I didn't expect it like that. Thank you for this awesome presentation.
Also, you ask so many questions. Okay, that all of your questions
Yeah,
were answered.
I benefit from this. I think this is good.
Okay, you are welcome. You can go right now, so you can catch up another.
Thank you so much.
Hassan Zuhair, are you here? Are you with us? Hassan Zuhair is absent. Ammar, are you here? Of course you are here.
Okay, many thanks, doctor. There is no comment. May Allah help you.
Okay, you are welcome. You can go right now. Jihad, are you here?
Yes, yes.
Okay. Any question, any problems, any suggestion?
Yes, I have a question.
Okay.
How are we going to take the quizzes and the homeworks and the finals, for example,
We
of term
don't
two?
know. Actually, no one knows what's going on or what will happen. What
For
we are
all, for all
to do is
quizzes?
just to cover the theory part. Regarding the exam part, I don't know what will happen because the quizzes online, I don't think is going to be available or not going to be with great monitoring. Maybe cheating will take place, maybe plagiarism. I don't know. I don't know if it's going to work or not.
Okay, do you know when we are going to go back to the university and take the classes like usual?
I don't know what will happen, to be honest.
Okay. Thank you so much. Thank you so
Thank
much.
you. You
I
are
really
welcome.
enjoyed it.
Okay,
Thank you
for
so much.
all of you here. Okay.
See you.